Okay, so now we look at the example 3 on the line integral for vector function. So we have the f is given, the just a 2D system, y, x and y. So now look at your C. C is a closed path. You have a closed curve shown in the figure. So it looks like, let's say you are starting at 0, 0, and then from 0, 0, you move to the 1, 0 along this curve using the x-axis, and then from 1, 0 to 0, 1, you follow this route. So this one, it looks like part of the circle, right? Because you can see the radius is 1 and the radius here is also 1. So now this is a circle actually. Okay. They don't mention it, but we can know from the point given. So because we see that the length on the x-axis is 1 and the length on the y-axis also 1. So this is we can consider this one is a part of circle. So that is another curve. And then from 0, 1 to 0, 0, we are using y-axis. So it looks like how many routes that we have, how many paths that we have. We got 3, right? From 0, 0 and go back to 0, 0. So we have a closed curve. What is a closed curve mean? Your starting point, your initial point and your terminal point is the same. Okay, so now compute how many curves that we have. So this is C1 along the x-axis, and then part of circle C2, and part of the y-axis is C3. So we have to evaluate the line integral of the given vector field along the curve, where the curve is the combination of the C1, C2 and C3. So for this, you have to calculate the line integral for the vector field for each curve. C1 plus C2 plus C3. Okay, so your F will be the same for all calculation, but your R, dr should be different. It depends on the curve that you have. Okay, so now we look at our C1. So we focus on the C1 now. So the C1 is the point of 0, 0 to 1, 0. 1, 0. Okay, since you can see that it is only contains the 2D system, which is just x and y. So, and then you can see that what is the variable changing. It is only the x, right? The x value. X is from 0 to 1, but y keep constant, which is 0. So it looks like instead of we solve this f dot dr in terms of dt, so we can compute the line integral using in terms of only x or in terms of only y. So now, okay, first we want to have the f first. So the f is minus y x. So the r here is dx dy. And there should be t, but the dt is gone because dr over dt, and this one also there is over dt, but then the t is gone. So that's why we can rewrite that into dr equal to dx dy. So when we have f dot dr, this one in general, okay, f dot dr, so we have negative y dx plus x dy. So when we substitute into the f dot dr, so we can have minus y dx plus x dy along the curve C. So the curve C, you can see that so in this case, as I mentioned before, the only changing is x 0, 1, but the y is a constant, does not change, which is 0. So when we know that this one is actually located on the equation, so at the same time you can see this one is located on the x-axis. So we know that the equation of the x-axis is equal to y equal to 0, isn't it? Y equal to 0. So then when y is equal to 0, then when you want to differentiate respect to t, for example, and since it is 0 and the dy also 0. So now what we can do is we replace the y and the dy into the f dot dr that we have. So this one is 0 dx, which will give you 0 plus x, and then your dy is 0. So since this one 0, no function, which is 0, and this one also 0, and end up to be the you will get a, you have to integrate the 0, and with respect to maybe this one we can say it is 0. So integrate the 0, you will get constant. Okay, but we know that this one is supposed to be, so end up to be 0 because all the integral here is 0. And as we know that this one should be definite integral, and you have to find the limit actually, but since it is useless because we know that for when you integrate the 0, and it end up to be a constant, right? And you have to replace the constant, just the constant. So let's say, okay, let's say your limit is a whatever t or b, a t or x or y, so a to b, and when you integrate 0, you will get constant, just a constant. So then you have to replace the limit of t or x or y from a to b, but since this one is just a constant, nothing to do with the value of x, y or t, and you will get a minus a, and the answer is still 0. So that's why you can provide me, because we know this one supposed to be has to do with the definite integral. There is a limit here, and since in this case we don't need to find the limit because it is useless, as we know that when we integrate the 0 integrand, and this is definite integral, and the answer will be 0. So that's why we can just say if this one 0, whether the integrand is 0 or the dy or dx is 0, so everything will turn up to be 0, and your final solution will end up to be 0 because this one should be definite integral. Line integral is a definite integral. You have to find the value. Okay. So now for the C1 here, it's end up to be 0. And now we want to go to the C2. So for C2, what is the information that we have? We have a point from 1, 0 to 0, 1, and it is passing through along the circle. Okay, along the circle. So for C2, okay, we try to look at the value of x. So x is from 1 to be 0 and y to be 0 to 1. So meaning that the x and y are changing. Okay, so in this case, so C2 is actually part of the circle. So we have to find the function where actually in Cartesian, it is a circle with radius 1. So you have x squared plus y squared equal to 1. As you can see here, the center is at 0, 0. Okay. So for this, if you transform into only x or into only y, you have to deal with the plus minus square root. So for me, it is maybe a bit messy later on. So why not we just change them into parametric equation. So here, the parametric equation here, we can see that just like a polar. Polar is a part of the parametric equation. So you have a circle with radius 1, So the parametric equation is r cos, so normally x is cos, right? So we have r is 1, so we only have cos t and sine t. You can choose the x to be sine, y to be cos, but next you have a problem. You will have no problem in order to solve the line integral, but you will get a problem to determine a correct or a proper limit of t. Okay, because normally we read when we assume that x is cos, which is we follow the polar coordinate system. Polar is a part of parametric, so normally x is cos, y is sine, then we can read the angle is starting from x-axis positive and so on. Okay, so for that normally for circle we follow the polar, so that it's easier for us to deal with the parametric in terms of polar later on. Okay, so in this case your vector r of that curve is given by cos t sin t. So we need to get the dr. So cos negative sin t cos t dt. So when you have a f dot dr, where in general we can use the f dot dr here. So now we put the negative y. So negative y means negative sine t. Negative sine t dx is negative sine t. Okay. And plus x. So x is cos t, and then dy is cos t dt. Then we have the sine square t plus cos square t dt. And this one can be simplified using identity. We only have dt, but we need the limit of the t. So now you have to determine from your r, you have to determine what is the t, so that you have 1, 0, and what is the t when you have 0, 1. Okay, so what is the t that can give you 1? So it is 0, right? Because when you set t0, so cos 0 will give you 1, sin 0 will give you 0. So for this, your t is 0. And how about this one? You have to remember the graph of cos. So what is the t? Then it will give you 0. This one. And at the same time, you have a sine. And sine you want to be 1 here. So it happened at pi over 2. Pi over 2. So then you can have t is from 0 to pi over 2. So t 0 pi over 2 will give you pi over 2. So this is your line integral for the C2. Okay, the C2. We got pi over 2. And then we have the C3. So C3 is a line segment, y-axis. So now we work on the C3. F dot dr for C3. Okay, what is the information on the C3? So you can see here, it is a y-axis. So what is the equation of y-axis? X equal to 0. So when x equal to 0, so dx equal to 0. And then based on that, we substitute into the general form that we have already set up here. So when you plug in, your dx is 0 plus x0 dy. And we know that this one should be definite integral, And because all the integrand here is 0, when you integrate 0, we'll get a constant when we replace the limit. So constant minus constant is end up to be 0. Okay. But if you want to check, maybe you want to just verify whether is it correct, the answer is 0, you can change the C1, because C1 we got also 0, right? You have to change C1 and C3 in terms of t, and I'm sure that your answer will be also 0. You have to find the vector function of the line segment, okay, in terms of t. So what is the formula I told you before? Always for the line, the vector function of the line segment or the straight line, always given by R0 plus TV. What is R0? R0 is the vector, the position vector, which is you can get from the point passing through the line, and V is the displacement vector or vector parallel to the line. Okay, so now we have to combine all the result. So just now, C1 we got 0, C2 we got pi over 2, and C3 we got 0. So the total summation, we got pi over 2. So that is the result of this example.